So, operations with functions. So, we have these functions, f and g. All a function is, it's an equation. Okay? So, last year when we were defining functions, or grade 10 when we defined functions, a function was something that for every input there was a single output. It passed the vertical line test. So functions, that you can have linear functions. You can have quadratic functions. You can have cubic functions. But you can also have functions that are not, or sorry, they wouldn't be functions. You can also have equations that are relations. They're not a function because they have more than one output. So if I put in something, an example of that would be the square root of x. So if I input 4, the square root of 4 can be a positive 2 or a negative 2. That would be an example of a relation, whereas a function could only have the one output. So the following properties can apply to functions, provided that x is in the domain of both f and g. So the sum of the two functions, I can add them together. I can take f of x and add g of x. The difference of two functions, I can take f of x and subtract g of x. The product, I multiply them together, and the quotient, I divide them. The only thing when I'm looking at division is I have to make sure g of x doesn't equal 0 because I can't divide by 0. So what we're going to look at today is we're going to look at the sum and the difference of two functions. So we're going to start off with a graph. So two functions, f and g, or f of x and g of x, are defined for all real numbers. The table of value shows the values of f and g for certain values of x. So when x is equal to negative 4, f of x is equal to negative 7, and g of x is equal to negative 7. If I went f plus g of x, it means I would add these two values. So if I add the two values, what would I get? Negative 14. So f of x plus g of x. In other words, f at negative 4, which is negative 7, and g at negative 4, which is negative 7, would give me f plus g at negative 4 being equal to negative 14. If I subtract them, what do I get? I get 0. So if I look at the next point, when x is equal to negative 3, the f function is equal to negative 5, the g function is equal to negative 6. If I add the two functions together, I would get, and if I subtracted them, negative 5 minus negative 6, 1. Okay, so I'm going to give you about 2 minutes. I want you to finish the column. You see a pattern that's going with when I add the functions? What's happening? It's increasing by 3 each time. And what's happening when I'm subtracting them? It's increasing by 1. So then what I would like you to do is sketch these 4 graphs. I'd recommend maybe using different colors so I can give you different colors to use, but sketch the 4 grids. What do you notice about all of these functions? What kind of functions are they? They're linear. So when I added the linear functions, I got a linear function. When I subtracted the linear function, I got another linear function. So if we turn over to the next page, we're actually given the equations of those 2 linear functions. F of x equals 2x plus 1, and g of x equals x minus 3. So if we were to write the expressions of the sum of the 2 functions, f plus g of x would be equal to 2x plus 1 plus x minus 3. So if I collect the like terms, I collect the x's, I would get 3x minus 2. And if you go back to the previous page, remember linear functions are in that mx plus b. M is the, and b is. So if you check that sum function, which was my blue one, when I add the two functions together, does it have an x-intercept of -2? Yeah. Does it have a slope of 3? Yes, it does. So it did match up. If I subtract the two functions, so f minus g of x, I get 2x plus 1 minus x minus 3. And it's important to use the brackets because when I collect my like terms, I get 2x minus x, which is x. And then I get x minus -3, which would be, the two negatives would create a positive, so I would get 4. And if you look on the previous page, is the y-intercept through 4? And does it have a slope of 1? Yes. And a common mistake that's made is if we didn't remove the brackets, we would forget, we would just think of it as a 1 minus 3 and we'd get a -2 instead of the positive 4. Okay. So part E where it says use a graphing calculator to verify them, we actually verified them using the graph and using the characteristics of the graph. Think of the domains and the ranges of these two linear functions. Do they have the same domain? Yes? Do they both have the same ranges? No? So how do they both have the same domains? They can be any value of x. So when I draw this out, I could put arrows at both ends, right? And the same with this one is I could have an arrow at both ends. So my domain can be any x value. What can my range be on my blue graph? Any y value. What about the purple graph? It's eventually going to be any y value because this line is just going to keep extending down indefinitely and extending up indefinitely. So then both domains are x is a real number, x is an element of the real number system, and both ranges is that y can be a real number. So with the next part, determine the values of f plus g of 10. What I can do is I can take 10 and I can substitute it into this equation that we solved above. So f plus g of 10 would equal 3 times 10 minus 2, which is 28. So on the graph, if I extended that blue line so that I could see when it reaches x equals 10, the y value would be equal to 28. If I look at f minus g of -10, I would get -10 plus 4, which is -6. And again, if I was to look on that graph, if I extended that graph to be at -10, the y value would be at -6. Now, part H says, in this example, the sum of the difference of the two linear functions, functions with degree of 1, were also linear functions or degree of 1. Can you think of two functions? Oh my goodness. Let's fix that. Can you think of two functions where the sum or the difference would not be a function, or a function that has a degree of 1? If I had these two functions, what would happen if I subtracted the two functions? What would I get when I subtracted them? (4x minus 4x), 0. 3 minus -7. Does this function have a degree of 1? No. If it doesn't have a variable, it doesn't have a degree. So this is a degree of 0. So if the functions have the same x value, or the coefficient on x is the same, when I subtract them, I would eliminate that x term. If they were opposites, so if I had f of x being 4x plus 3 and g of x being negative 4x, when I added them, again, those x terms would cancel each other out, and I would be left with a constant term. Okay? So now let's look at quadratics. The graphs of two quadratic functions, f of x and g of x, where x is an element of the real number systems, are shown on the grids. The points marked with dots have integer coordinates, which means this point right here is at 24 for the y value and 3 for the x value. So it's just to reassure you that this point right here lies on the cross section of the grid. Okay? So use these graphs to sketch the graphs of f plus g of x and f minus g of x. So I'll work through f plus g of x with you together, and then the other one you'll do by yourself. So what I need is I need to look for common x values. So the first common x value that I have is when x is equal to -3. What is this value right here? Is it 2? What's the y, what's the y value here? These are going up by, what's my scale? 2. And this looks like it's right in the middle, so we can assume it's 1. And that's the other reason why the integer coordinates comes in, because if it's an integer, it has to be halfway in between. It has to be the 1. Okay? What's the y value on my f of x, the quadratic that points up? 24. So then in my function where I'm adding them together, what's 1 plus 24? 25. So the new point is going to be halfway in between here, and it's still going to be on this x equals -3 line. So now if I look at when x is equal to -2, what is the value of my quadratic that opens upside down? What was the y value? 4. And the quadratic that opened up had a y value of 12. So when I add them together, I get 16. So then my point goes on 16. So what are my two y values when x equals 2? 4 and 5. So when I add them together, I get 9. So it might actually be easier if we made a chart. Do you think? So and when I say make a chart, what I mean is something like this. I think I have to pull it down a bit. And then when x was equal to -3, then I can write in what my f and my g values were. So when x was -3, I had 24 and 1. So when I add them together, I got the 25. When x was -2, I had 12 and 4, which gave me the 16. And when x was equal to -1, I had the 4 and 5. So when I add them together, I got 9. When x was equal to 0, I can erase these numbers now and just leave the points. When x was equal to 0, my quadratic that opened up was equal to 0. The quadratic that opened down is equal to 4. So when I add them together, I get 4. Then I've got when x equals 1, I've got a value of 0 and 1 for each graph. So then when I add them together, I get 1. When x equals 2, I've got a value of 4 for my up one and -4 for my down one. So then when I add them together, I get 0. When x is equal to 3, I've got a value of 12 and -11. And so when I add 12 and -11 together, what do I get? 1. Extends on to 4 and 5, I think, fit, or 4. So when x equals 4, I have 24 and -20. And so when I add them together, I get 4. So if I joined these points together with a smooth curve, because what you can see is you can see that it does get to this minimum point and then comes up again. So if I join this together, that's what my f plus g of x graph would look like. So what I'm going to do is give you a couple of minutes to do the f minus g of x graph and see how you do on that one. So if I give you the functions for the expressions, f of x equals 2x squared minus 2x, and g of x equals -x squared minus 2x plus 4. If I add these two functions together, I get 2x squared minus 2x plus -x squared minus 2x plus 4. So 2x squared plus -x squared would be x squared. -2x plus -2x. And then I have a plus +4. So I get x squared minus 4x plus 4. Which if I check this graph, which is in blue, that is that equation. That is that graph. If I subtract them, I've got 2x squared minus negative x squared, which equals 3x squared. And then I have negative 2x minus negative 2x is 0. And then I've got negative positive 4. So I would get minus 4 in that case. And I can double check it in that it has to cross the x-axis at negative 4. Or sorry, the y-axis at negative 4. What are the domains of these two functions? X can be any element of the real numbers. So X can be a real number. So in this case, again, the sum and the difference of the quadratic functions resulted in another quadratic function. Can you think of an example where it does not result in a quadratic function? So what did we do with the linear functions? How did we make two linear functions, the sum, not equal a linear function? When we had the same number of x's, because we canceled out the x term. So how do I make a quadratic function not a quadratic anymore? What do I get rid of? The x squared. So as long as I take two equations and give them the same x squared value. So give me a quadratic equation.
6x squared plus 3x minus 5.
Okay? Is that a quadratic function? Yeah. So what would the other quadratic function have to be in order to have a sum? Let's make this, we should have that as f of x. So what would g of x have to be in order for the sum to not be a quadratic? Negative 6x squared. The sum would no longer be quadratic because the x squareds would cancel and I'd be actually left with a linear function. And if I made them the same, if this one was a 6x squared and this one was a 6x squared, the difference between the two of them would no longer be a quadratic. Okay? So let's look at cubic functions. If I have two cubic functions and I add them together, what will I get? So if I take x cubed minus 2x squared plus 6 and I add it to x cubed minus 2x plus 6, what would I get? So I want you to add and subtract them. Anyways, 2x cubed minus 2x squared minus 2x plus 12 would be the result if I added the two functions. If I subtracted the two functions, the x cubes would actually disappear. And then I would get negative 2x squared, a positive 2x, because I'd be subtracting a negative 2x, and then 6 minus 6 would also disappear. So if I complete the following statements, f of x plus g of x is a sum of two functions and can be written as 2x cubed minus 2x squared minus 2x plus 12. And f of x minus g of x is a difference of two functions and can be written as f minus g of x, which equals negative 2x squared plus 2x, which also gives us an example of a situation where the sum or the difference of two cubic functions is not a cubic function. If I go to evaluate these, I will let you work on that while I fix the screen again. So f plus g of negative 2 means I can put negative 2 into this equation. So 2 times negative 2 to the power of 3 are cubed, minus 2 times negative 2 squared, minus 2 times negative 2 plus 12. So what is negative 2 cubed? Negative 8, and negative 8 times 2? Negative 2 squared is? And 4 times negative 2? And then negative 2 times negative 2 is 4, plus 12. So what is negative 16 minus 8 plus 4 plus 12? What is it? Thank you. I saw somebody nodding. So I heard something and then I saw nodding. I'm like, I don't know. And then if I have f minus g of the square root of 6. So this would be negative root 6 squared plus 2 times root 6. So what is root 6 squared? 6. And what's 6 times negative 2? So I get negative 12 plus 2 root 6. Okay. The last question just gives you an idea of where you could use function notation. A multimedia production company produces DVDs that cost $3 per unit. The fixed costs, including graphics, are $10,000, irrespective, which is just a fancy way of saying doesn't matter how many DVDs you order. So each DVD retails for $15. So if X is the number of units produced, answer the following in terms of X. So the cost as a function of the number of units produced. So how much does it cost me to produce the DVDs? Just $10,000? Plus 3x. So the $10,000 was my setup cost. So C of X would be 10,000 plus 3x. What's the revenue of the number as a function of the number of units produced? So revenue is how much money am I bringing in? 15x. Write the company's profit as a function of the number of units produced. How do I determine profit?
You take how much you make and subtract it by the cost of those two.
So how much I make was my R of X, and I subtract C of X. So that becomes 15x minus 10,000 plus 3x. So if I simplify this, 15x minus 3x, so I get 12x minus 10,000. So the last question is determine the company's profit if 20,000 DVDs are produced. So profit, which would be P of X, would be 12 times 20,000 minus 10,000. Roya? And I could also do this question and figure out what is my break-even point, how many DVDs would I have to sell in order to pay for everything, and that would be letting P equals 0 and then solving for X. So there's different things that I could do. So your questions are 1, 2, and then 6 through 9.